Sure. Sounds like me. Exponential graphs. I like so. Okay. I'm going to draw you a table which you can copy because with the exponential graphs, we don't only look at one value to determine the shape. Die vorm word bepaal deur 'n kombinasie van A en B. So I'm going to draw you a table and I'll give you time to copy it and then I'll explain the table to you. Okay. Goed. Kyk, ek sal gou vir julle tyd gee om daai af te teken, dan gaan ek nou vir julle verduidelik wat daar aangaan. Het julle hom? Because I want to spend some time on these shapes, so I don't want you still drawing it so that you can follow and understand. Almal by? Okay, I'm first going to look at this row. Because that you did last year. Jy het laas jaar gekyk na die effek van B. So, let's quickly look at the formula again. It's important that you notice that B is the one that has the exponent. It's obviously not always going to be a B. Nee? Gaan nie altyd. Hulle kan vir jou byvoorbeeld sê f van x is gelyk aan a tot die mag x plus q. B is whatever is standing, I almost want to say, under the exponent. So a B is wat ook al 'n exponent van x het. It's very important that you see that. Okay, so in the format that I wrote it there, under the exponent, we have a B. So we're looking at that number. Almal by met wakers. Okay. Daai getal kan nie 'n negatiewe getal wees nie. It will never be a negative number. So if you have maak dit sommer plus 8. If you have that, wat is die waarde van A en van B en van Q in daai geval? What's the value of A? Minus 1. What's the value of B? 2. So basically what that is, it's a minus 1 times 2. But it can't be negative 2 to the power of x. Ons teken nie sulke grafieke nie. Volg julle wat ek sê? So it's a minus 2 to the power of x. But B, the thing that has an exponent of x, cannot be a negative number. Hy moet groter wees as 0. Ja, ons weet. Hy moet groter wees as 0. En as hy lê tussen 0 en 1, like for instance, if I have y is equal to a third to the power of x. Do you guys agree a third is between 0 and 1? Then it has this descending shape. Okay. As ek het, y is gelyk aan 3 tot die mag x. In other words, bigger than 1. Then it has the ascending shape. The dotted purple line is my asymptote. All of you got that? Okay, en daai twee is altyd vir wanneer A positief is. So for when A is negative. So an example of this would be y is equal to a third to the power of x. And this one is y is equal to 3 to the power of x. Nou al wat gebeur wanneer ek na die ry onder dit toe gaan, is hy reflekteer eintlik net in die asymptoot. Do you guys see that these two are mirror images of one another? And these two are mirror images of one another. So let's say this one would be, for example, y is equal to negative a third to the power of x. And this one will be y is equal to negative 3 to the power of x. So basically they just reflected in the asymptote. Hy het omgeval. Okay. Goed, almal by tot daar. Kom ons kyk hoe lank hierdie laptop nog gaan hou. Goed, die keywaarde gee vir jou die asymptoot en hy skuif hom op of af. That you guys also did last year. And then lucky for us, this one doesn't have an axis of symmetry. It doesn't have and it doesn't have another asymptote. It only has one asymptote. Then you can also write down for the domain. So vir die definisieversameling gaan dit wees x is 'n element van alle reële getalle, lekker maklik. And for the range, if A is positive, then you say y is bigger than q. And if A is negative, then it will be y is smaller than q.